Alright, so this is the third video in our third unit, and we're going to go over factoring patterns. These types of equations you can still do it the long way, but I'm going to go over kind of some shortcuts that happen when we run into special scenarios. Alright, so the first one I'm going to factor kind of the long way, just so you can see what it looks like. So x squared minus 16. If you notice, our b term is missing. We don't have x squared plus 6x minus 16. It's x squared minus 16. So if I multiplied my a and my c, I need to choose factors that add to 0 because my b term is missing. So if I came over here and actually factored this, I would choose 4 and negative 4 because those add to 0. And I factor out an x that they both have in common. In the second set, I'm going to factor out negative 4 that they both have in common. And my factors end up x plus 4 and x minus 4. Now, I'm going to give you a tip here. Anytime the b term is missing, you take the square root of the number, and those are your factors. So the square root of 16 is plus or minus 4. So my factors are x plus 2, x minus 4. So if you're missing your b term, you don't have to go through the long way standard factoring. We can kind of cut corners. So if you look at the middle one, we have 9x squared minus 25. So when we have an equation like this, we can also cut corners because we're missing our b term. So on the last one, I'm going to need to take the square root of 25. So that's plus 5 and minus 5. Because if you look back at the first example, I took the square root of 16, got plus 4 and minus 4. So those were the two numbers I plugged in, or x plus 4, x minus 4. However, if you look at this equation, you have 9x squared minus 25. So with this 9, it's not just going to be x plus 5, x minus 5, because then if we redistributed, we wouldn't get our 9x squared that we need. So we also have to take the square root of a and put that with x. So the square root of 9 is 3. So this is going to be 3x plus 5, 3x minus 5. So when you're missing your b term, you need to take the square root of a and put it with x. So the square root of 9 is 3. So I put 3x in both parentheses. Then you need to take the square root of c, in this case the square root of 25, and you put plus 5 and minus 5 in the parentheses with your 3x. So if we're missing a b term, take the square root of a and take the square root of b and throw them in parentheses together. The last one we've already seen some in class. I just haven't addressed it as the class. A lot of you have already noticed that this happens. But I'm going to show you just in case, because in the next video we're going to talk about completing the square. And this is going to be important for that process. So here we have our b term. So we're going to need to multiply a times c and factor like we talked about in video 3.2. So a times c is 1 times 9. My factors of 9 are 1 and 9 and 3 and 3. So I need to choose factors of 9 that add to 6. So I'm going to use positive 3 and positive 3. I rewrite my middle term 6x as 3x plus 3x because I chose 3 and 3 from my factor tree. I look at my first set of parentheses and take out what they have in common. X squared and 3x both have an x. X squared divided by x is x. 3x divided by x is 3. The second set of parentheses, I also take out what they have in common. Here they both have a 3. So I factor out the 3, and that leaves me with x plus 3. remember to make sure that what you have in both sets of parentheses is identical, or else we messed up. And here, what we have is the same. So my first factor is what's inside the parentheses, so x plus 3. My second factor is what's outside the parentheses. In this case, that's also x plus 3. So why I'm calling this a factoring pattern is really just we have the exact same factor twice. X plus 3 happened 2 times. So that means that our final answer is going to be x plus 3. And if it happens 2 times, that means it's x plus 3 squared. For those that like why this is true, all this means when we have x plus 3 squared like this, all it means is the x-intercept happens twice.